Today I will talk about a mechanics problem, A-level, paper M1. So we are told that we have two particles hanging from a smooth pulley. The pulley is smooth and is fixed. Smooth means that we have no friction. Initially, both particles hang vertically 30 centimeters above the ground. So this is the pulley, the first particle, the mass is 600 grams, so M1 is 600 grams, that makes 0.6 kilograms, and M2, the second particle, 400 grams, that is 0.4 kilograms. It means the weight of the first particle is 0.6 times g. I shall take g approximately 10 meter per second squared. As you know, it's 9.81, but we can use this approximation. And here the weight is 0.4 g. They both hang at 30 centimeters, that is 0.3 meters above the ground. The particles are kept like that and then they are released from rest. This is the tension in the string. According to Newton's third law, we have action and reaction. The string pushes on the pulley and the pulley pushes on the string, and the same way the masses pushes on the string pushes on the pulley. They exert a force of equal magnitude and opposite direction, as it can be seen. So when they are released from ground, obviously the particle, the heavier particle, will move downwards, so we have a downwards acceleration here. Therefore we have an upwards acceleration here. We are told that the particles are at rest, so the initial velocity is 0 meter per second. So we can find the final velocity when the first particle reaches the ground. What we are asked to find is what is the maximum height that M2, the second particle, can reach. So when the first particle reaches the ground, we can write that v squared, the final velocity, is u squared plus 2as. Therefore v squared will be 0 to the square plus 2 times a times 0.3. So we have to find the velocity of the first particle. When we examine only the first particle, we can write Newton's second law, the resultant force equals mass times acceleration. F resultant equals mass times acceleration. The resultant force, being given that the first particle moves downwards, is 0.6 g minus t equals the mass is 0.4 times acceleration. In the same way, for the second particle, we can write t minus 0.4 g equals 0.4 a. I write the first equation below here, 0.6 g minus t equals 0.6 a. And when I add the equations, t and minus t cancels out. 0.4 g minus 0.6 g minus 0.4 g, 0.2 g, 0.2 times 10 is equal 0.4a plus 0.6a, a. Therefore, the acceleration of the system is 2 meters per second squared. Now, the moment the first particle reaches the ground, the second one will have the tendency to move upwards according to Newton's second law, the law of inertia. So the first particle is down, m1, and the second particle will continue to move upwards for a while. But there is no more tension in the string because m1 is not pulling anymore, right? So we have the weight m2g, the acceleration in the second part, the acceleration 1, is going to be minus g. So now we can write here that the resultant force, that is the resultant force, is m2g equals 2 minus m2a. So we can see that the new acceleration is a1 is minus g. The initial velocity is the final velocity of the first part of the motion, that is u is equal to v, and v was equal to 2 times a, that is 2, 4 times 0.3 square root, so that is 2 square root of 0.3. So u is 2 square root 0.3. The final velocity when m2 stops is 0. Therefore we can write v squared equals again u squared plus 2a s1. So 0 is equal 4 times 0.3 plus 2 times minus 10 times s1. And when we make s1 subject of formula, s1 will be equal to 4 times 0.3 over 20. That is 0.06 meters. So the maximum height will be equal to, I will call it h, will be equal to 30 centimeters from the beginning, 0.3, plus 0.3, how much the second body has moved, plus 0.06, that is 0.66 centimeters, that is 66 centimeters.